Now the trapezoid rule works okay if you have fairly simple functions, but there are some cases, especially if your function is kind of curvy, where the trapezoid rule is actually fairly inaccurate. It doesn't accurately approximate the function. So trapezoid rule is not that accurate. So for example, if I kind of draw another sketch, we have a CP versus T, and our, I'm going to exaggerate it a bit. We have a function like this, and our two data points were here. If we drew a trapezoid here, the area would be the shaded in part, but then there's this part that's not included in the trapezoid, right? It's not counted. Right, so the area encompassed by the trapezoid is actually a little bit less than the total area underneath this section of the curve. So here's just kind of one example. But even if we go back to the slides and kind of look here, right, we see that the trapezoid rule works okay, or works okay for this segment. But once the function gets a little bit curvier, we see that the trapezoid here is actually has a larger area than what's actually underneath the curve, right? The trapezoid is overcompensating. In this case, here it's also overcompensating. It's bigger. Then here, it's smaller than the actual area underneath the curve, right? So if your function is a bit complicated and you have something that's very, sinusoidal or something, the trapezoid rule is not that good of an approximation. Now, there's different ways to improve the accuracy. One thing you could do is you can make the distances, you can make what we call the mesh size smaller, because that would decrease the error or the inaccuracy. Basically, the smaller a distance you have to cover, the better that trapezoid is at approximating the curve. So that's one strategy for doing that. Another thing you could do is, rather than approximating the area underneath the curve as a trapezoid, what you could do is you could approximate it as 3 points in your curve as a parabola, right? And so that's what's known as Simpsons Rule. Right? So Simpsons Rule, rather than taking 2 points and saying they're a trapezoid, what Simpsons Rule does is it takes 3 points and then fits a parabolic function to them, so that it does a better job of accounting for the curviness of the function. Right? So if we go back to the notes, I'll just write out that Simpsons Rule is a more accurate way to numerically integrate. So instead of fitting a straight line between 2 points, a parabola is fit between 3 points. Okay, so if I go to the next slide, if I redraw that sketch I had, where I have CP versus T, I have a similar sort of function. But now, rather than 2 points, I'm going to draw a third one here. What Simpsons Rule does is it'll approximate this part as a parabolic function. Okay, where this is area of a parabola. Okay. Now, if you remember from geometry, for a parabola, the area encompassed by it is A, which for area is h over 3 f x of 1 plus 4 f of x2 plus f of x3, where this h is interval between data points. Okay? So Simpsons Rule starts with that sort of concept. Okay? But to generalize the equation, I'm just going to write the final result. Right? So based on this concept, what Simpsons Rule state is the following, where if you're integrating some data, f of x, from x1 to xn, Simpsons Rule is going to break down into this formula. Plus 4, the summation of j equals 2, 4, I'm going to write that 2 better, 2, 4, 6, dot, 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 n minus 1, f of xj, plus j is equal to 3, 5, dot, 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 n minus 2, and there's a 2 here, f of j, and then close parentheses. That's the final function for Simpsons Rule. Some things I want to point out. So we have these kind of terms that have sums in them. The one here where you see j is equal to 2, 4, 6, this one accounts for all the even terms. And then the following term accounts for all the odds. All right. Now, Simpsons Rule, once again, it's used or is developed because it's more accurate than the trapezoid rule. However, there are assumptions that are required that need to be satisfied in order to use Simpsons Rule. So, only valid when those two main assumptions are, or requirements, not even assumptions, are the number of data points that you're trying to integrate over. It needs to be an odd number of data points. Remember, because in order to form that parabola, we need 3 data points in there, right? And then the interval between each of those data points has to be constant, because we're just using one h value. So h is the same. Okay.